Happy Halloween, everyone. I figured we'd do something fun today. And by fun, I mean the exact same thing as always, but in a lab code. Alright, here's the plan. I finally, late last night, I figured out the bug that was making it so that we couldn't train anything in the C++ trainer. I'll show it a little later. It was horrible. What we're going to do here is I'm going to go through, we're going to fix up the consistency check so I can prove that the Python trainer and the C++ trainer are exactly the same. And then we're going to start stripping out all these like slow things I've done for testing. I want to see how fast we can get pufferlib to learn. Flip the stream on over. All right. Here's pufferlib CPP. And if I recall, yeah, so this is on CPU in C++, 160 something thousand steps per second, very slow by puffer standards, very fast by everybody else's standards, and it is trained. Almost perfect perf. So, what we're going to do next, a few things. First, I'm going to show you the test that I wrote. Here's your puffer check. Yeah, puffer check. And then we'll do this on CPU. And it's going to spam us a whole bunch. And you can see that I had been messing with this. I'm going to fix this up. We're going to have a clean test. Get this watch off as well. It's bothering me. I haven't gotten any heavy lifting in either, so I'll have some fun for Halloween. All right. Start by commenting out all these frickin' prints. Yeah, you see, I'd been like, this is the amount of debugging I've been doing. I've basically been going through every single possible tensor, checking every number to the 10th digit, making sure there was no difference between CPP and Python. And like, there is going to be some very small difference at the end of the day, because the numerics backends are not guaranteed to be the same. But from what I've seen, it's pretty damn close. And even when there was a bug, it was still pretty close. I'll show you what that bug was in a little bit. Okay, so there's your check passing with Adam as well, right? I was using SGD for a bit, blech, in order to make that work. Oh yeah, we need to make sure that everything passes though. Welcome, Son of Liberty. I am a huge fan of C. What problems do you have with Python that it is so slow? It is so ungodly slow. And then the shit that people do to make it fast is literally worse than writing it in C. I can't even tell you how many times I've seen Python code that's more complicated than low-level code that's still slower just for the sake of perf. It is unbelievably stupid. I am sick of this language. I could be persuaded to do things other than just C if if there were actually adoption for any other, like, good language, but realistically, I don't think that there are any other widely used languages that are good. Okay, so if I do 5 of these, the obs is going to mismatch. Can I do 3? If I can get 3 epochs with it being numerically the same, that'd be nice. Following Mojo at all? Not really. There are some good things with that, and then they just screwed up some other things, and also it's like a company making a language that's just never going to catch on. Okay, so I guess it's just 2 epochs is all we get, or maybe even 1 training step plus eval. 1 training step plus eval is fine for this test, honestly. Alright, so yeah, we're gonna have... As long as this one passes, we're happy. Okay, there no cell anything in here, so we can just do... We can actually totally simplify this check. You know? This whole check right here. And then we'll get rid of this ATOL, because on a init it should be exactly the same. Not just kind of close. And then let's see, we got args. Train optimizer equal atom. Backend. Policy. Load env. Yeah, that's a good check right there. Make sure this still runs. Welcome, Sarvesh. I guess you don't like Rust because it's so inconvenient to write in. Yeah, because it's inconvenient to write in, and the error class that it solves is like not a big error class. I don't spend my time worrying about fucking memory safety, all right? People shouldn't be allocating so much damn memory in the first place. Or so often, at least. Like, program init, allocate your structs, cool. Use your structs, free all your stuff, end program. Obviously, you have to do some intermediate stuff sometimes, but, like, it's mostly a C++ thing, honestly. It's just every frickin' standard library thing allocating memory under the hood. Was waiting, you didn't stream? I did the Yaxine podcast in the morning yesterday. That was what I was counting as the stream. I've had some other stuff to take care of this week. I'll probably be streaming more next week. I've also gotten this whole big thing done, though. Welcome, mechanics. Alright. So, we have the test running. That the implementations are identical. Are you wearing a lab coat? Yes, I am. Happy Halloween. Thoughts on Super Maven? Yeah, Super Maven is the only usable thing out there. Honestly, I might just go back to not using AI in my work, like in my programming. I don't write that much Python anymore. I might just get an LSP and call it a day. Right? The whole thing was that the LM autocomplete was useful in the first place because LSP kind of sucks in Python. But I could just use a standard LSP and I'd probably be 70% as good. So contact. I've chatted with that guy in person before. The requirement though for podcasts is that it's not like some like high level bullshit where's AI going in 10 years, right? If it's technical and about actual work, then that's cool. Welcome, Tech AI. Okay, so let's get rid of the the CPU requirement. Yeah, see this? I've moved everything to the CPU because I thought maybe the numerics were screwing us up there. And they might still be screwing us up. But we're gonna just do this first and we're gonna see if this is good enough. If this works, we'll be able to start actually getting some real perf out of this, yeah? Is it a costume if you're a doctor? Heh. True. But you know, I always thought it was super lame that you get to the AI lab at MIT or Stanford or whatever, and it's like a bunch of dudes, like mostly skinny dudes in blue jeans with no actual equipment. No lab coats, no like fancy like, tech in the background, like friggin' laptops, man. Lame. Cursor and windsurf getting accused of using Chinese lightweight models. Teh. I don't understand why people think that like these are good. They're just bad. Like stop using them. You're a bad programmer. Just stop. Learn to write your frickin' code. Using LLMs for docs these days is unfortunately kind of required because people just stopped bothering to write good docs because they assume that you're just going to type them into an LLM anyways. So that's at least understandable. And docs includes like example code because your docs should just have a bunch of example code. So that's forgivable. We went to the lab in hoodies and PJs. Heh. That's funny. Are you aware of Toading? Yeah, I've seen his stuff. Seems cool. You can build with just the C compiler. Well, wait, you don't need CMake. We don't have CMake on Puffer's stuff either. We just have, I mean, we don't use C for our build script. You very well could, I guess. We just have like a simple bash script. build.sh, right? Alright, what the hell's wrong with this thing? Segfaults. Give me a trace. What am I developing? Ultra high performance reinforcement learning. It's all right here on puffer.ai. Oh yeah, I wanted to go find the command, but real quick, did we hit 4K? No, we're 12 stars off from 4K. Can we hit this today? That'd be awesome. If you haven't started the repo, start the repo. It helps a lot. Right, we were gonna do stack trace CPP. I forget the flag name. It's like torch CPP. Yeah, shows CPP stack traces, right? Spencer's new env? Yeah, Spencer's been doing cool stuff. Grep app search. Huh. Is that just like AI retrieval so you get real code? Or what is it? Search is GitHub. Cool. Why is this just giving me a segfault? This is dumb. I've only got 2 hours for streaming, I think, today, so we're gonna try to crank some good results. I want to get like a full demo of this CPP trainer on stream today. That'd be good. Ugh. What is this? Python threading. Do I need to rebuild everything? I'm confused. Try this, and then we'll see if I can get myself a proper trace. No idea mechanics. Should be pretty good. I want Puffer 4 to be 10 million plus steps per second, though. Specs computer, do we need to train a model? Well, for the 100 some odd thousand steps per second, you need a potato. And for what I'm doing with my normal stuff where I'm getting several million, I'm on a 4090. We have plenty of users on other GPUs as well. Just a desktop, like a good desktop for some of the higher perf stuff. All right, so what is happening with why is Python segfaulting? God, I hate Python. Well, I don't know what this... Should I focus on learning reinforcement? Are you interested in it? I'm not going to tell you, like, should you or should you not study a thing, right? That's, are you interested in the thing? If you're asking about if it's a good field to get a job in, I'm not the right person to ask on that. Just not how I think about things. Obviously, I've made a job out of it, but... No, we should be able to get a trace out of this. What the hell is happening here? What is happening with this? No Python frame? Like, what? I can try the Python one. Yeah, okay, so this trains, right? Okay, can I just, like... I mean, how is this even in threading? That's like, I'm not threading stuff. They shouldn't be able to segfault there. Freaking torch are being weird. Without this, it's just segfault, right? Alright, we'll try this. Alright, so I don't understand why this is segfaulting, and I don't understand why I can't get a trace. Normally, I should just be able to get a trace. Let me see if I can get a debugger. I don't think so, though. If I can't get a trace, then I shouldn't be able to get debugger, but... Messaged you a while back on Twitter chat. I will show you what my DMs look like in case I missed that. Alright, this is what my frickin' DMs look like. It's like all frickin' spam, so I do miss stuff occasionally. Let me see. Is your name Aditya on X? Okay, I don't see it, so either send me something else or tell me the name that you sent it under. Like the handle. Oh, on the stream chat? What? I messaged you a while back on... Like today? I don't see any messages from Aditya today. Like, if you mean you've been around in general, then yes, I remember an Aditya. Oh, you dummy. Why does this segfault instead of, That's really weird that this segfault's here instead of giving me an actual error. This is CUDA. GDB to the rescue. Can't... Well, why would that segfault? That's weird. Went through Pufferlib, also watched your PhD, defended thesis, super cool. Autonomous driving company and working and planning. Oh, cool. Yeah, there are a couple driving companies that are apparently using... The main thing we do in that space is we've got a port of NYU sim. So, you know, they built this GPU drive sim, and we did a port of it to Puffer. It's way faster now, and they're using it, and a bunch of other folks are using it as well. Thank you. Work's been inspiring. Hope to work for you someday. Thank you. If you're interested in doing stuff generally, like, all of Puffer is open source, and there are a heck of a lot of things around here that we have all sorts of people working on. I'm currently working myself on the major stuff for 4.0, but you know, if you have planning benchmarks, little test M's in mind, things that you think are like hard to solve, but we think we should be able to solve. Most of these M's are just by contributors, and some of them are pretty useful in research. We just merged this thing in properly finally the other day. Okay, there we go. So there is Puffer squared training 4 million. 4 million steps per second. Can we run check? That's so annoying that there's literally a CUDA backend difference. What if I just put the ATOL to, welcome. Is this still, like... Alright, let's see how big of a difference this is. Oh, that's a really big difference. Okay, so something I think is probably broken here. Does this train? It does train. Okay, we'll have to keep an eye on this then. So we'll just do, yeah, hang on. Let's make a very dedicated commit here. Hello, welcome. All right, that's the first chunk of thing done. Yeah, convert. We got a prototype of the CPP working. We're gonna do some perf stuff on it right now. Well, right after first bench set of the day. All right. Still got the 200 for 8. Haven't been doing enough training lately. The C++ implementation's been bothering me. We'll see if this gets it to be any faster. It should. There's also probably a redundant synchronize. Try this first. Okay, 4.5 mil. See how this goes. Okay, this works just fine, it seems. Morning, Jess. Okay, so the CPP is a bit faster. It's just that all the speeds globally are down for whatever reason on the desktop right now. And this is not the area where we think it's going to give us the most speed benefit either. So that's 3.9. Four 4.4, 2080, and then when we do here. Okay, interesting, it's saying that the train loop is faster in Python, which makes no bloody sense at all. So let's figure that out. Right? Yeah, it's saying that the eval is faster, but the train is slower. Get rid of all this crap. We got it to run, Jess. So we have some training. And it's a little bit faster than Python, but there's still some things to debug to, like, figure out why we're not getting the full expected speedups. Stuff is not easy. Okay, we'll start with this. We're almost at 4K stars. If we hit the 4K on stream, I'll pull the I'll hit the first 2-plate bench in quite a while. In celebration. Shouldn't be that hard. Alright, so it's 3.5 for Python, and then 4.3. Now let me figure out, I think there's something about how I'm doing the stats. We've got dot item here. Right? See what's taking up all our time. Slower? How the heck can it be slower? How much is this costing? This whole thing. It ain't got no gas in it. Yeah. Let me just make sure I didn't screw up the time zone. I have an important meeting later. We're finishing up a bunch of client things for the end of the month. Okay, at 2 p.m. Cool. I'm gonna have to go a little bit before 2 though, because this my audio does not like to work. I'm probably gonna have to take meetings from my phone, which sucks. Okay, so there's the 4.3 back. So you actually lose a lot of perf just in these like stupid loss calcs. So I think it's 4.3 is as fast as it gets, right? So you don't need dot item. Mm, mm, mm. Okay, there's our 4 mil, whatever left. Should be able to get this over 5 mil though, if I remember. Seems like the trainable is slow, right? autocomplete gives you such stupid stuff sometimes. Like, much easier here. Alright. Making progress. Making progress. What is this error? Long int. Really? There's no way to divide. Alright, we'll try this. Still no? Does this have to be double? It's like, hey, I don't know how to divide by a float. Like, the hell? Invalid cast from type C10. Okay. Alright, what's wrong with this? Like... Type safe wrapper. That's incredibly stupid that you have to do it with, C++ is just dog shit, like... Okay, 4.4 million steps per second. We got this. Now let's see how much overhead we're losing, like how much perf we're losing. How much perf we're losing to all of this logging in general? 4.4, 4.5, then. Okay, no meaningful perf loss from this, as we expected. Local AI dev learns to manage types. I know how to manage types. Ask the fucking C++ devs if they know how to manage types. Thing is, like, C++ is like, you know, that kid in school that would just raise his hand to ask clever sounding questions that if you thought about for more than 2 seconds were completely fucking stupid. Yeah. I know, because I used to be that little shit. But if you just look at this, it's completely stupid. Like, what? Why did we have to reinvent what the fuck a cast is? Million ways to do everything. And they're all dog shit. Okay, well, we got the implementation up to something reasonable. There should be an equivalent. Oh, that's even dumber. So it's not. You don't even get max. You don't even get kernel selection in this. Okay, this is completely brain damaged. There should be a way, though, to do this. How the hell can there not be a way to do this? Great. So brain dead, man. This is like so brain damaged. I don't understand how the hell you have so many engineers working on stuff and you get something like this. Like, why the fuck would this be dependent on this? Working on this. Eh. I didn't know there's such thing like online RL and offline RL. Well, the article I wrote says that there isn't a thing as offline RL. Offline RL is really supervised learning. But online RL, the idea is you're learning by interacting with the environment. Right? It's like you're learning by trial and error plus algorithm. I'm trying to figure out, though, hang on. There's still something weird with this, isn't there? Because if I do this, right? So 50-50, right? So each forward and back train and eval are running at about 7 million steps each. And then here, this is running at like 5, and this is running way faster. Isn't it a problem that an algorithm doesn't know what's important? That's what RL does, is it figures that out. I can't actually tell with this whether this thing's slow or is my test in the other one wrong. No, see, we still have... It's, like, very clear cut here. Oh, hang on. Let me go check one thing. Yeah, so this is totally the case then, right? That the Python... Somehow the Python train loop is faster. We have to figure out what's different between these two. Never all cover... simulation is still used extensively, and our simulations run really fast. Like, we can literally train on thousands of years worth of simulated data on one server. You can't cover all possible cases directly in the real world either. There's some amount of robustness in generality. 1 second, guys. Alright. Packages. Welcome everyone from YouTube. We're having a little fun here on Halloween with perf optimization. Well, fun meaning doing the exact same thing as normal, no lab coat, but... Yeah, welcome, Jess, yeah. How you been here? I mean, pretty much it's just a matter of, like, why... It's 20% compute and 70% compute. Like, the split is totally different, right? Unless... Now, see, this has frequency set to 1 already. This thing actually has... Yeah, the full uptime covered. Oh, but wait, this doesn't call synchronize. So yeah, this might not be timing correctly. Let's try this. No, this is timing correctly, it seems. Yeah, so this is timing correctly. Oh, but this one might not be timing correctly. Okay, this one is timing correctly, and it actually gets even slower. So at least now we're seeing the perf. But this one is still training faster, I believe. Right? Because this is like half the time. Or, hang on. Is that right? No. No, this is just saying the env is running slower. Okay, I think it's fine. Yeah, I think it's fine overall. It's a good speed up. Let's try the 16. Any good? Trying to get into 16-bit. Oh yeah, and we're going to be able to do B-float as well, which will be better. No faster. That is a little odd, no? For this thing not to really be any faster. Let me just make sure something screwy is not going on. So if I'm right, this should not train, right? Yeah, so this doesn't train, that's correct. I want to see what they're doing with AMP now. Okay, so I'm pretty sure this is doing... Yeah, this is doing exactly what I would expect. Let's just get the whole thing to do this first, and then we'll see. And so you have your 16-bit here. See what this does. Okay, 7 million. Except we're not actually training correctly. And get Cerebrus open. Okay. AMP is actually not bad like this. This bot. Yeah, we don't need to have these two policies, I don't think. We're gonna get another bench set in. We're gonna get AMP at least. It'll be good. Okay, so there's the scoping thing. Cool. I think we just don't need to do... Yeah, this is like implicit namespace, right? Okay, it's kind of cool that you can do this, but it's a heck of a lot easier if we just do it this way. What are we dealing with? Torch CUDA AMP has not been declared. Yeah. Oh, I forgot the include, didn't I? Yeah, dummy. Hang on, I just forgot the include. Okay, now I'm confused. I assume you mean 1.2.x. I don't, you stupid. What are your honest thoughts about Dreamer v3? It's like the most beautifully written paper ever, and it's like completely misleading. It's like probably the most misleading paper I've read. Yeah, that shit does not remotely work anywhere near as well as there's written on paper. I've spent a ton of time on it. Multiple of the best RL researchers I know have spent a ton of time on it. That thing is a piece of shit. And model-based RL in general, maybe, but that paper is the best evidence for it, and that paper is garbage. So, I've wasted enough time fucking with model-based RL. It doesn't work. There is only like half a reason to think it should work, and I'm not wasting any more time with it until there's like substantial reason to. There's really like nothing I can ask other than like, hey, why does nothing fucking remotely work as cleanly as described in the paper? Why is all of the reasoning given for everything completely backwards and wrong? And like, yeah. No, Pufferlib is model free. Well, I mean, Pufferlib is more than just the training algorithm, right? But the algorithm we use is model free. Model based in this sense means that you're directly constructing a predictive model of the future. So Pufferlib is training an agent without explicitly constructing a predictive model of the future. JEPA don't know enough about. But that's like pretty far off of the type of stuff I'm doing here. Dreamer's the thing that's superficially kind of close, and that just doesn't work. How does it know what to do? I mean, read the tutorials, right? You don't need you don't need an explicit planning model in order for these algorithms to work. And oftentimes that explicit planning model is just super slow. They very well, it's actually guaranteed that implicitly they are learning some sort of world model. Whether it's going to be implicitly to some extent, yes, it's just a matter of degrees. Is it not in here? Dude, why do they implement shit like not at the C++ layer? Okay, so PyTorch is just kind of bad. That's annoying. Yeah, that's bad. Well, I can still do it. I just can't use this. What and for what do you see minus minus? It's a joke. It's C++, but I hate C++, so I call it C minus minus. You can try this. That's kind of obnoxious, though, that they just never implemented it. Is there actually a language called C minus minus? Heh. That's funny. Yeah, that's niche enough that I'm gonna keep using the joke anyways. But that is very amusing. No, Son of Liberty, it really wouldn't be. Because you're not using a lot of the fancy C++ stuff anyways for the low-level ops. You could and look, technically CUDA is CPP, but like the actual kernels themselves really aren't. You could very easily have like a C-like interface that just gives you direct access to optimized kernels, you know, a simple auto grad, and a lot of the stuff that you actually want out of Torch when you're doing this type of dev, and they just didn't. It's like 100 times more bloated than it needs to. Maybe not 100 times, but it's at least 20 times more bloated than it needs to be. You find... Well, I'm not using it, so no. I'm currently using Super Maven, which Cursor bought and is killing next month. So I'm probably going to go back to just not using any AI complete. I'm probably just going to get an LSP finally. And be done. Jess, you come build it with me. If you want it to exist. That would be... It'd be a pain in the ass. It would definitely be a pain in the ass. Because PyTorch is a really big project. So yeah, people have done it, but nobody's actually like put in the work to make it a mature library, right? I mean, realistically, I suppose you don't even need that many things. But like, it's difficult because it's very difficult for projects like this to grow because nobody knows how the fuck to program anymore. So like everybody just wants their shitty Python interface to everything. And they like expect a bunch of dumb things to be there that you don't actually need. I don't know. Maybe I'm just getting old and grumpy, but last bench set. We're gonna make this run at least, and then I gotta get ready for my meeting. So Jess, the thing to do would not be to go implement all of Torch to start. The first thing you do is go see, like, if you can just get custom fused kernels for our networks. There'd be a lot more for there. Well, it runs, and it's stable, but it's half the speed because the LSTM does not have good kernels. Okay. We'll keep this, though, because that's the next problem to solve. Okay. Happy Halloween, folks. I will be streaming a lot early next week. We're really going to try to hammer out the perf optimizations. We're getting close. We basically need to have either a BF16 kernel or an alternative cell architecture. Ideally, an alternative cell architecture. I think I'm going to play around with min-LSTM, min-GRU. If you enjoy the content here, this is all free stuff. It's all at puffer.ai. If you want to help me out for free, absolutely free, start the repository. We are 10 stars off of 4,000. So feed the puffer a star. It helps a lot. If you want to get involved with development, most of which does not look like this horrible low-level optimization. Most of it's like chill, low-level game dev that actually benefits science. Discord's here, docs are here. And if you want more content, follow on X. I post a whole bunch of stuff. It's all technical. And a lot of long-form content as well. It's not just like 2-sentence bits. Occasional fitness thing, but mostly just research. Thank you, and I gotta get to my meeting.